Multiplying radicals. For non-negative radicands, the square root of a times the square root of b is equal to the square root of the product. So you can multiply the separate radicands underneath one radical symbol to combine. Let's look at an example. We have the square root of 5 times the square root of 10. So we are allowed to multiply these underneath the same radical. And instead of just multiplying, we'll go ahead and break them down so that we can simplify. So 5 is already broken down, and 10 will break down to 2 times 5. And now if we're going to simplify, it's a square root. We have 2 copies of the 5. So that is a square. We can take 1 copy to the outside of the radical for that group. So we're taking the square root of 25, will be a 5. And the 2 is going to be left underneath the radical. So 5 times the square root of 2. For our next example, let's multiply square root of 3 times square root of 3. This will give us the square root of 3 times 3. And then when we simplify, this is a perfect square because we have 2 copies underneath. So the 3 is going outside. This is going to simplify just to 3. So whenever you multiply a square root times itself, it will just remove the radical symbol and give you the part that's underneath. Let's multiply square root of 3 times square root of 27. So they are both positive square roots, so they can go under the same radical. And then we'll break the 27 down. So we have 3. We can do 27 on the side. 27 is 3 times 9. And 9 is going to be some more 3's. So 27 has 3 3's. And we already had 1 3 there. So square root means we're looking for groups of 2 factors. Here is 1 3 to go outside for this group. And 1 3 to go outside for this group. And there is nothing left underneath the radical. So 3 times 3 will give us 9 for this answer. Let's look at one more of this kind. Square root of 12 times square root of 15. So both are positive square roots. We're going to put them under the same radical. 12 times 15. And we're going to break them down. So for 12, we'll do it on this side. We can do 4 times 3. And 4 has some 2's. So 2 times 2 times 3. 15 is 3 times 5. And those are primes. And now we will simplify this radical. So we look for the squares. The 2's give us a square. So 1 2 can go outside for that. The 3's also give us a square. So 1 3 will go out. It will multiply by the 2 out there to give us 6 on the outside times the square root of 5. Our rule is true for other roots as long as we have the same index on the radicals being multiplied and non-negative radicands. So we can multiply these, put them under one root symbol. It will still be a cube root. We have 4 and an x, and we have a 6 and an x squared. We will break those down. 4 is 2 times 2, and we have an x. 6 is 2 times 3, and x squared gives us 2 x's. And now let's look for this cubes this time. So we have to have 3 factors to take one outside. So our 2's give us a cube, 1 2 to the outside for that group. The 3 does not have enough partners, so it will have to stay. The x's give a group. So that's a cube, x cubed. 1 x can go to the outside for that group. We'll put the radical symbol back on. Make sure you keep your index. And all we have left underneath is a 3. So 2x times the cube root of 3. Let's look at another example. 3 times the square root of 2 times 2 times the square root of 5. You will just multiply the numbers that are on the outside of the radical. 3 times 2 is 6. And then multiply the numbers that are underneath the radicals. 2 times 5. And those are not going to break down, so we have 6 times the square root of 10. What do you think we would do on this example with the parentheses? We would distribute. Looks just like a distribute problem. All right, so we're going to do square root of 2 times the square root of 2. We'll just put them under the same radical. Or if you remember, when you multiply the same square roots, it will take the radical off. We'll also do square root of 2 times the square root of 3 underneath. For our first one, it's going to give us a plain 2. And the second one we'll have to multiply. It's not going to simplify. So just distribute like you would expect. Here's another example. And we will distribute square root of 5 times the square root of 2 and square root of 5 times the square root of 10. So square root of 5 times the square root of 2, we'll put them under one radical. And square root of 5 times the square root of 10. We can break the 10 down. For the first one, nothing simplifies for us, so it's just going to give us square root of 10. For the second one, we can break 10 down to 2 times 5. And this one gives us a square. So for the 5s, we can take a 5 to the outside. The 2 is going to stay underneath. And our first one was simplified. So square root of 10 plus 5 times the square root of 2. We have one more problem here to distribute, and just notice that you have numbers on the outside of the radical. So you will multiply things on the outside of the radical and underneath the radical. So for our first one, we will multiply the 2 times 3 on the outside, and underneath the radical, we can go ahead and multiply 3 times 5 is 15. That is not going to break down because those are both primes already. And then we'll distribute to the second one. The 2 times 2 will multiply on the outside to give 4. And 3 times 2 will multiply underneath. Those are also both primes, so it is not going to simplify. And that takes your parentheses off. For our next example, this problem is like multiplying two binomials, so a FOIL process. So we will do our first terms. Square root of 5 times square root of 10. We'll just put them both underneath for right now. And then we'll do outside. Square root of 5 times a negative 1. The negative 1 is not underneath the radical, so it's going to go on the outside. So a minus 1 times the square root of 5. You don't have to write the 1. You can if you want. Then we'll do the inside. The 1, 2 is going to stay on the outside. And then we have 2 times 10 on the inside. And that was first, outside, inside, and now last. This one will also multiply by 1. Be careful, your two negatives will give you a positive. 2 times 1 is 2, and you still have your square root of 2. Now let's see what all will simplify. On the first one, the 10 we can break down to 2 times 5. And we can take 1 5 to the outside for that group. So 5 times the square root of 2. We have square root of 5. That one's not going to simplify. On the next one, we can break down. The 10 will do 2 times 5. So we have a 2 underneath and a 2 times 5. So for the 2's, a 2 is going outside. It's going to multiply by the 2 that's already out there. So it'll give us minus 4 times the square root of 5. And our last term, there is no simplifying we can do. Now let's look for like radicals. The square roots of 2 are like radicals. Remember to combine them. You're going to combine the numbers on the outside. So 5 plus 2 will give us 7. you keep one copy of the radical. The square roots of 5 are also like radicals. Work with the numbers outside, so we have a -1 and a -4 to give us -5, and you keep the radical just like it is. Let's look at one more problem that looks like multiplying two binomials. So this would also be done as a FOIL. So we'll do our first terms. Square root of 5 times square root of 5. Remember, when you multiply the same square root times itself, it takes the radical symbol off to give us just a 5. Then we'll do outside. 2 times the square root of 5. 2 goes on the outside. Then we'll go inside. -2 times the square root of 5. And then we'll do last. -2 times 2 will give us a -4. And our outside and inside terms are going to cancel on this one. And we can combine 5 minus 4 to get 1.